Aloha, Richard Halverson here. This is ITS128, and this is the second week. And today is, like August 31st. So I'm going to continue. We're going to start chapter 2 today, but first of all, I'm going to answer some questions that somebody had in chapter 1. So let me share my screen. Share screen 3. Okay, so here we are, and this is this time. Yes, it is. And if we look at the syllabus, we are in this week, and let's see. So let's I didn't do this, but I really should go and see where we ended, how the labs work. Oh, that's that. Oh, that's nice. It's not important. Okay, 1.12 is where I ended. All right, so that's fine. Okay, great. All right, so let's see. First of all, I wanted to mention that I went through the forums earlier today. So if you remember, or if you posted something on here, let's see. There was a good here assignment questions. Okay. Well, the reason it doesn't look like it's read because this is me as a student reading it, and I'm a lazy student, and I haven't gone in and read any of these, but Richard, the instructor, has. But I just wanted to mention this exchange here that two of you had, I think, is really good. I mean, this is what this is trying to encourage, and in fact, I didn't even have to say anything. You guys kind of figured it out. So that's very good. So you guys will get extra credit for this because you posted it up here, and it's the benefit of others. It's completely to the benefit of others, and there I got a lot of questions on this particular problem here. So anyway, that's great. Let me go back to and I got oh wow, that's great. You guys all did that. Okay, anyway, so let's go to the textbook. And somebody had a question on oh, here we go. All right, so somebody had a question on 1. By the way, I've gotten some questions about deadlines. Again, I can do this because it's auto graded. Okay, if it weren't auto graded, it wouldn't be this way. Okay, because I'd have to figure out when I'm going to grade, when I have to grade, and then I want you to hand stuff in before then, of course. But because it's auto graded, the only advantage to my going in and downloading the grades and uploading them before the day after the day after the end of finals, the only advantage of my doing it before then is for you, so you can see it. It's just you should be able to see it in zyBooks itself, but you won't know the weighting. You don't see the weighting of all the participation activities, the challenge activities, and the labs. So the deadlines that are posted are recommended deadlines. The deadlines so you don't fall behind. They're deadlines so you keep up. So you keep up with your assignments with my lectures. I'm going to assume that you're about where you are in the syllabus as far as assignments go, and so that's what my little lectures, my little video lectures will be about. So bottom line is, don't worry about the deadlines. I don't take off points for anything. No, there's not going to be a midterm. There's not going to be a final. It's all on the points that you get doing the exercises in this book here, and the other posted things. The gradebook classic here, you see you're going to get 20% on all the participation activities. It's easy. You just click through them, right? Just got to click through them. It's easy. 20% on all the challenge activities. They're a little bit harder to click through. There's not as many of them either. But you know, you can get through those, and in the videos I cover them almost all of them. The videos. If you have problems, just tell me to cover it in the next video, and I will. And then the lab assignments, these are a little bit more difficult. That's why they're 50%. But I do go over, you know, almost all the labs, or I at least get you started on other labs. I might not on the really easy ones, but so these take a little bit more work, and these actually are demonstrating your ability to write programs. And then this is so you become knowledgeable in all the areas, in all the industries that Python is being used. If you end up writing Python programs after you're done graduating, you could be in any field. You could be anywhere. You could be in nursing or culinary, or you could be you know, paralegal. There's all kinds of disciplines and careers. You have a chance. You're more and more likely you'll have a chance to do some coding to make your job easier. It's all about automation, and and Python is an easy one. All right, so that's that. All right, so let's get the first question. Somebody had a question on 1.3.5 challenge activity. So I'm going to go find 1.3.5. 1.3. Is it in here? Is it 1.3? Talking about input and output, printing and inputting. 3.1, 3.2, no, 132, 133. Anyway, it was 135. Let's go down to 135 and see what that is. Wow, it was a long one. Okay. Read user input and print output. Read 3 integers from user input without a prompt, then print the product of those 3 integers. In other words, if the input is 235 and the output is 30. Yeah, right. And this is in the first chapter of the first Python class of the first Python book you've ever seen. So that tells me a lot. This is a very poor description because your input is not going to be like that. It's going to be 2 enter and 3 enter, 5 enter. It's not going to be 2 space 3 space 5. Our system will run your program several times, automatically providing different input values each time to ensure that your program works for any input values. Okay, so we're supposed to put the solution here. Well, you know what I like doing? This is a good time. Well, this is a challenge activity, right? Okay, so you just got to do and get it right. I'm gonna pop open an editor. Here's a nice editor, and I'm gonna type what I think should be the program over here. So the first 3 things we need to do is ask the user for 3 inputs, and without a prompt. Okay, I think I know what they mean. So I'm going to say integer 1 is, and then you say input like that. Really? Oh, int. Okay, that's better. Okay, we're basically doing this. Num1, num2. Okay, let's just do that one. I'll call it num1. Num1 is, this is going to ask the user for an input. Actually, what it's going to do is it's just going to, everything is going to stop, and it's going to start, and it's just going to be looking at the keyboard until you type some stuff in along with an enter key. And once you hit an enter key, it's going to take a look at what you typed, and that's what's going to be there. And presumably you're going to type some characters that are digits. And so we need to convert that to an integer number, because instead of typing in a 5, the character 5, we're typing in the value 5 integer number. It's confusing, I know, but you'll get the hang of it. So this asks the user for an input, and once the user types an input followed by a return key, then this takes that input and converts it into an integer. Now, if the user types in a letter, then this int function is not going to work, because it can't convert a letter to an integer. So your program will bomb. But anyway, so we got to do this 3 times, and each time we need to call it something different, because otherwise it's just going to write over the old one. It's going to write over the old one. We don't want that. So this asks 3 times, and then what is it supposed to do? Is it supposed to output the product, the product. Okay, so we can say prod is equal to num1 times num2 times num3. That's the product of the 3 numbers. And then we got to print that out, so you just do print prod. Okay, so that should work. Now, so let's see if it works. Okay, so I'm going to save this on the desktop, and I'm going to save it in my 128 folder here, and I'm going to call it challenge 1-3-5.py. And then I'm going to pull up I've installed Python on my computer here, so I need a command prompt. I need a CMD right here, and then I gotta go to the desktop. Might do that. CD desktop, does that work? I don't think so. CD OneDrive, CD desktop, dir. Okay, there's my ITS128, CD ITS128. Okay, now I'm in ITS128. I'm going to do dir, and there's my challenge. Okay, so and I'm going to do Python. Do I just do Python or Python 3? Just Python will work. Exit. So I can do Python challenge. Now, can I hit the tab key? Oh, yes, look at that. I can just hit the tab key and it finishes it for me. Enter. Okay, now it's just sitting there. It's waiting for this. It's sitting right there. Okay, so all right, it's waiting for me to type something in. All right, I can do that. I'll type in 10, enter. What's it doing? Oh, it's waiting for me. It's sitting right here. Okay, well, all right. And I'm going to put in 5, enter. And then it's the same thing. Okay, now it's right here. And it is, so I'm going to put in, so 50, I'm going to put in 11. No, I'm going to put in 50. It's at 50, so I'm going to put in a 5. 50, I'll put in 2, be 100. Okay, and then it outputs 100. Okay, now when they say, excuse me, when they say without a prompt, I'll show you what a prompt is. Right inside here, this input thing, I'm going to put enter the first number, colon, space, end the quote. Enter the first number. Now put in the second number. I'm just being kind of dumb here. Does that work? And then I can put in here one more number, whatever. Okay, that's a prompt, and I'll show you now when I save this, and now when I run it. Oh, look, enter the first number. Okay, 3. Oh, and now put in a second number. Okay, the 5, and then one more number, 10. Okay, I don't know. So anyway, that's that. Well, you should have enough information now to put in a solution there, and it should work. Remember, if you followed what I just did and you did all that, don't put the 3.5, right? Don't put the take the prompt out of there. So I think that'll work. All right. The next question this person had was, unfortunately, and also 1.13 and okay, 1.13 and 1.17 labs. All right, well, let's do some labs. This one. Oh, I see. Okay, so that is right. Okay. All right. Okay, so let's do this one. I don't think I did it before. Auto-graded programming assignments have numerous advantages, but some challenges too. The students commonly struggle with realizing that the example input-output provided in an assignment specification and leaves input and output, but the program should only output the output parts. If the program should double its input, then the instructor might provide this. Okay, so the program should double its input. Okay, so what they're saying is that when they give you these examples like this, you have to pay attention to what of this is what the computer prints out at you, like the prompt I just did, like what it displays out at you, and what is there because you type something in. So in this example here, probably what it is the computer prints this out, and then it sits down here and waits for you to type something in, and then you type in a 5, and so that's why that 5 is there, and then you hit an enter, and that's why it's down here, and then the computer prints this out. Okay, so the computer doesn't print this out. That's from you typing it in. So when you see instructions like this, you got to make sure, you got to pay attention to what they're actually showing you. Okay, so really what this is saying is that students often incorrectly grade a program that outputs the 5. Instead, the program should only output the output parts. See, so the program should output this, and then the program should output this. Okay. This is only there because after after it printed out this line, it sat there on an input function, waiting for the user to type some digits into the keyboard, followed by the enter key. All right. So that's that. Okay. Okay. So the program below incorrectly echoes. Okay. So try submitting it for grading it, and notice that the test case fails, and the first test case highlights remove the codes. Just all we have to do is just fix this. Okay, that should be pretty easy. All right, so I'm gonna submit it. Oh, really? Oh, okay, that's this one. Okay, I'm gonna submit this. And it says nothing. Why doesn't it say anything? What's going on? I'm confused. Well, it's because you're supposed to put what when this executes, it's going to look down here at something you typed in. No, not there. Oh, no. Never mind. Forget that. If you go in development mode, it'll, wait a second, what's going on here? Why didn't it? Did I not hit run program? Okay, here's where you type in the input for this. But but it's submit mode. Can I, what happens when I, is it, oh, okay, I must not have clicked that button. Okay, so the problem is, see, so the problem is that the student printed this out. Okay, if look, I'll show you. I'm going to take this here. I'm going to take this just like this. Copy. And I'm going to put it over here and here. And I'm going to just do a new one. New. And I'm going to do paste. And I'm going to do save as. Save as. Save as on the desktop. Test2.py. I don't know if I have a test.py, but so then I'm going to run Python test2.py. Okay, so enter X, and I'll type 5, and then it prints out 5 again, and then it says X doubled is 10. You see, so this is how it looks when this is executed. Well, to fix it, you don't want the computer to print this 5 out right there. Okay, this is the 5 that you entered in. See, look, I'll do it again. Say enter 5 or enter X. Now I'm going to type a 6. That's my 6. Now I'm going to hit enter, and then it prints out another 6 here. You can't see my point. And it does it. So basically, to fix it is you would simply take this thing out. I never like taking things out. I always like to just make a comment. Okay, now when you run this, yeah, and I'm going to put the 5 there. That's me putting the 5 there. Enter, and then it just says X doubled is 6. Okay, so this is what this should look like. So in other words, you should take that out. Okay. But you'd never know it by doing the development mode thing here. See, so I'm going to do 5. And I'm going to run the program. And you look at it and go, oh, yeah, oh, that's right. That's what it's supposed to be. Oh, yeah, that's so I got it right. And then you submit it, and it goes, wait a minute. Oh, I thought I got it right. Anyway, so that's what's bad about this system. And they're working on a fix for it. Okay, soon this textbook is going to have, when we have these windows here, it's going to look more like this. Okay, so you won't have to deal with this mental thing where you're doing it different. You really are doing it differently here than you are doing it here, and sometimes that can be confusing. And that's why they spend time like this on it. All right. I better put this. Just in case someone wants to say something. All right. Also, this person had a 1.17 lab. Well, let's take a look at that. All right. Write a program that takes the first name as input and outputs a welcome message to that name. Oh. If the input is Pat, the output is, hello, Pat, and welcome to CS Online. So here it asks for the input, and then you're going to type some code in here so it prints out this. Okay. So let's see, user. So when you read it in, it comes in as username, and this is where the code would be. So I'm going to start by so I'm going to stepwise refine. Stepwise refine is okay. So first I'm going to do print username. Okay, and I'm just going to see what this does. I'm going to put Joe Schmo, and I'm going to run the program, and it's going to say Joe Schmo. Okay, that's good. Pat. I'm going to put Pat. Run program. Okay, there. So I got to put some stuff. So I got to make this come before Pat, and I got to make this come after Pat. Okay. I wonder how I can do that. So I need to make this come before Pat, and this come after Pat. Now when I run it, and welcome to see it. Hello, Pat. Oh, no, that's not right. Well, anyway, oh, did I get, I'm not doing the right one, am I? So anyway, so I purposely made that mistake. I purposely made this mistake, and you, of course, just have to fix it. That's what they're getting at. Sorry, I did the wrong one. This is the one, Mad Lib. What? Oh. Okay, I guess I did get the wrong one. Okay, so this is dumb. This is a dumb one, okay? Is this mode the default template? Oh, okay. All right, so let's do this one. Okay, Mad Libs are activities that have a person have the user provide various words, which are then used to complete a short story in unexpected and funny, he says in a hopeful manner, ways. Complete the program to read the needed values from input, and then, okay, so basically, you're going to read, you're going to ask the user for 4 words. Word 1, word 2, word 3, word 4. And then what's going to print out is word 1 went to word 2 by word 3, different types of word 4. Okay, so that's what's going to happen. See, here we go. Word 1 went to word 2, 2 by word 3, different types of word 4. So, but this print statement does not call it word 1, word 2, word 3, word 4. It calls it first name, generic location, whole number, and plural noun. Okay, that's what it calls it. So you do something like first name equals input. This is what you do, just that. Generic location equals input. Okay, and so you just do that for the 4 of them, and you know, it outputs correctly. If I run this now, if it's going to get an error because it wants you to print out what whole number is and what plural. Okay, this is going to be defined. This is going to be defined. In fact, here's what I'm going to do. I'm going to do this instead. First name is Joe. Joe Schmo. Went to CapCC. CapCC. We're supposed to call it CapCC, not KCC, because don't want to get it mixed up with Kauai. And the third one is whole number. So it's a whole number equals 100, whatever that is. And the fourth one is plural nouns. So plural noun is something like I don't know, how about courses? Okay, so now what happens when we run this? I just run, there's no input. See, I've defined everything. And it's going to say, Joe Schmo went to CapCC to buy 100 different types of courses. Okay, okay, but these are hard. Joe Schmo is hard coded, CapCC is hard coded, and this and this are hard coded. So you want instead to be an input. So now it's going to ask for one thing, but these are still hard coded. So here you put, oh, look at this. Your program expects an input. Well, that's pretty smart. So I'm going to put first name of Pat Chang. How's that for a generic name? Run program. Okay, Pat Chang, blah, blah, blah. So anyway, the next one you want to do is let's make this one be an input. So the next thing it's going to want is a whole number, 5. Okay, so the first time it asks for something, it wants the first name, and the second time it asks for something, it wants the whole number. So now when we run this, it looks like Pat Chang divide 5. Okay, so you want to make them all inputs, and then when you test it, you want to put all 4 of them. Okay, so that's easy. All right, so that answers the questions I have. If you have any more questions, oh, by the way, if this person would have posted these questions on the forum, that person would have got a little bit of extra credit. Don't worry, there's lots of time to get extra credit. And really, you post 1 or 2 or 3, and that's about it. That's about it for extra credit. I mean, you can keep on doing it. Maybe it'll get gradually less. I'd like to encourage you all to participate at least once. That'd be nice. Some of you will participate a lot. That's really good, especially if you have really good questions. And they can be suggested answers too, or solutions, or why didn't this work? Those are good questions. All right, so let's start chapter 2 here. So now we're going to learn about variables and then how you assign variables, how you assign values to variables. So what is this one? Remembering a value, okay, concept of variables. So you should click through this. For each step, keep track of the current number of people by typing in the number of people, box. It's editable. Okay, great. Okay, so we're going along. It says you're driving a bus. The bus starts with 5 people. 3 people get on. So what are we supposed to do? We're supposed to add 3 to 5, and we get 8. Yeah. Oh, I got it right. All right, what's next? This is like a challenge. 2 people get off. Well, that brings it down to 6 now, I think. So you have to know, to take this class, you should know how to add, okay? But you don't have to do much more than that. You have to learn some tricks with how equations work. You have to understand operator precedence, because you have to write code sometimes to do the operations separately. But you certainly don't have to know what the Pythagorean theorem is. All you have to do is take the Pythagorean theorem and that somebody gives you, and you write it on one programming line. That's the trick you have to learn how to do. This though is very simple. It's a concept of a variable, and a variable that's changing. This is a changing variable. You're always going to see this on the left side of what's called an assignment statement. An assignment statement has an equal sign. It's got a variable, equal sign, and then some expression that's computed and stored back into the variable. All right, so what's next? 4 people get off, so that brings down the 6 down to 2. And then what? 5 people get on, brings up to 7. La-di-da-da-da. 4 people get on, brings up to 11. La-di-da-da. Oh, I got the check mark. Okay, so you just got to do this. Get the points. I should have answered a wrong one to see what would happen. All right. So in a program, a variable is a named item. An assignment statement assigns a variable with a value, such as x equals 5, takes 5. Value 5 gets stored into x. And it keeps its value of 5 until some future statement might do something to it. So the right side can be an expression. It can look like this, it can look like that, it can look like this. So the right side is computed into something, or it already is something. and then that's stored into the left side. So it's not algebra. It's actually a thing. It's an action. It looks over on the right side, evaluates that expression, figures out what it actually is. It could just be a number, but it could be an expression, and then it stores it in. So it's not the same as algebra. Algebra is different. The equal sign is different. The equal sign means something different in programming. This equal sign is like an action. It performs an action, whereas in algebra you're stating a fact. All right, so you want to click through that so you understand the difference, and then indicate which assignment statements are valid. Well, this one's valid because this evaluates to a number, and then there's a single variable on the left side. There's a single variable on the left side. Single variable on the left side. There's not a single variable on this side. Okay, so this is not a valid statement, and this is not a valid statement because you have that on the left side. You can't have anything that you have to evaluate on the left. There can only be a single variable on the left most of the time. There's some exceptions in Python. Python lets you do two things at once sometimes, and so you can put two things on the left and two things on the right, and they'll both happen at the same time. So anyway, so you should click through these just like that. You get all the points. Variables and assignment statements. Given the variables x, y, and z, x is 9, y is x plus 1. What is y? Well, it's 10, right? 9 plus 1 is 10. Store that into y. What is y? It's 10. Oh, by the way, just go like this and see the answer if you wanted to and put 10 in there, but that's sort of defeating the purpose of all this. But my point is, if you don't, at the very end, if you don't get all these points, it's either because you didn't need them because you got your A anyway, or you otherwise came to the conclusion that it would not have helped your grade. But you know, that might not have been true. All right, so you want to click through these. Participation activity, trace the variable value. Select the correct value for X, Y, and Z after the following statements execute. Well, this is kind of a fun thing to do. It's a participation also. Okay, so X is 2, Y is 0, Z is 8, X is 5. So X is 5. You can just go backwards. X is 5. Z is 8. And Y is 0. Yeah, right. Okay, you can go backwards. Y is 9. X is 5. Z is 8. Now you can't go backwards if there's any kind of expressions here, because it's going to depend on what happened previously. So you have to go. You actually should be going from top to bottom. But since these are all just constant values, I know that anything up above doesn't matter because it gets overwritten down below. So Z, Y, and X, it's these last three values. Okay, so anyway, you can do those. Enter, oh, here's a challenge. Enter the output of the variable assignments. What time is it? Okay. Start. What's the program's output? Okay, 7 space 4 enter. That enter is important. In fact, I'm going to not put the enter to see what it does. Oh, look, I didn't get all the points. All right, it's going to make me do it again. It's the same problem. All right. Okay. No, thanks. All right. 7. Isn't this the same problem? Y is 4. Okay. Is this a trick question? X and Y. 4, 4, space 3. Oh, X is 7. 7, space 3. Enter. Okay, anyway, you can do the rest of them. Assignments with the variable on left and right. Okay, so here, you notice we have we can have these assignment statements where we see the target, or the target variable is also part of the expression on the right side. Well, that's okay. On the right side, it's the old value, and all we're doing is we're using the old value in some computation, and that's going to be a new value for it. Okay, so this starts out with x equals 1, and then we have x equals x times 20. So this is 1 times 20. So now 20 goes into there, and now looks like we're going to do it again. So this is 20 now, 20 in there, times 20 equals 400. So now 400 goes into here. Okay, that's what this is. So you can click through that, make sure you get those points. Indicate the value of x after the statements execute. Okay, so x starts out equaling 5, and then we take 5 and add 7 to it, and that's 12. So this is now 12, and so the answer is 12. Okay. All right. So you can do more of these. Oh, that's this. Okay. X equals x times y. So 2 times 3 is 6. So now this is 6. And now it's 6 times 3 is 18. So now this is 18. Am I right? Am I right? Yeah. Okay, this takes y, adds 2 to it. That's 32. Now this is 32. And this takes 32 and adds 1 to it, and that's 33. So now this is 33. See? Complete this statement to increment y. Y equals increment. What does increment mean? Do we define increment anywhere? Do you know what increment means yet? Well, anyway, increment means add 1. Decrement means subtract 1. I guess you could say increment by 5, and that means you're adding 5, but really increment just means by 1. So anyway, so it's y equals y plus 1. Y plus 1. Y plus 1. Plus 1. I wonder if I'll get points if I do plus. The convention is y equals y plus 1, but really y equals 1 plus y should work also. Yeah, I got the points. Okay, here's a challenge activity. Write a statement that assigns this variable with the sum of nickel count and dime count. So that means take nickel count, add dime count to it, that's the sum of it, and store that value in total coins. Okay, in other words, 100 nickels plus 200 dimes equals 300 coins. Okay, we start out with total coins equals 0. Should always initialize your variables. And then we're going to read a new value for nickel count, and we're going to read a new value for dime count. And we've got to put a solution there. And the result is going to be whatever this is. Well, it's just such an easy problem. Let's see. Is it total coins equals nickel count minus dime count? Is this correct? Oh no, it's not correct. Well, should it be times? No, anyway, you know what the end. Just put the right operator in there, and you can do this challenge activity. I don't want to tell you all the answers. Excuse me. I wonder what happens if I do this. 2 times nickel count plus 2 times dime count divided by 2. Let's see if this works. Ah, it doesn't like the decimal point. It doesn't like the decimal point. Well, how about if I do this? 8. Ooh, I got all the points. Well, anyway, so all I'm trying to prove is that the grader does not examine your statement to see if it's correct. The grader executes your program to see if the result is the correct result. See, so I can put anything in here, you know, any fancy expression I want, just as long as it's nickel count, just as long as it can evaluate to nickel count plus dime count. That's goes into there. Multiply the current value of the variable. Write a statement that assigns this equaling this multiplied by 10. So this is equal to, oh, so I have to take this and multiply it by 10. So I just have to take cell count and multiply it by 10. Well, there's lots of ways I can multiply cell count by 10. But one way is I can do this, well, cell count equals something, something says cell count, something, something divided by 10. That's wrong. It shouldn't be divided by 10. It should be something else. Look, I'm off by a factor of 100. That's because instead of multiplying by 10, I divided by 10. So anyway, you can fix this equation. You know, it says asterisk performs the multiplication function. So you should be able to get that one. All right, identifiers. Now, you know, we talk about a variable name, you know, like on the left side of the assignment statement and so on. Well, what are the rules for a variable name? Well, the more general term for the name variable name is identifier, because we also have function names and other kinds of things where we name things, and those are identifiers. An identifier has to start with either a letter or an underscore. An underscore is just like a letter. You can think of an underscore just like a letter, okay? And of course, you use underscores if you really want to. You know, you cannot have spaces in variable names, but sometimes you want the variable name to describe more or less what it is, and you know, you want to put a space in there, so instead you put an underscore. Anyway, so variable names can have underscores in them, and they can start with letters, start with underscores, and then after the first letter or underscore, you can also have letters, underscores, and digits. You can have digits. Okay. So that's what a variable can be. Python variables are case sensitive. You know, not all languages are case sensitive, but most of them are now. So capital CAT is different than lowercase cat. Two different variables. Big cat can be something, and little cat can be something completely different. And the Python interpreter doesn't see this as any way resembling this. All right, this cannot be a variable because it starts with a number, starts with a digit. But this can be, this can be, this can be, this can be, and so on. This can be. should be avoided because Python has special usages for double underscore names. So this is underscore underscore init underscore underscore. Certain words are reserved words, like this is a reserved word, this is a reserved word, and false capital with a capital F is a reserved word, or with a capital or this is also a reserved word. That's funny. So anyway, valid names. This is valid. This is valid. 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 Not valid because it's got a space in it. Not valid because it starts with a digit. Nothing wrong with this. Can't have this exclamation point. I mean, as much as you'd like to. This is fine. Oh wait, this might be a reserved word. I don't know if this is a reserved word or not. Python output reserved word. I don't know if it is or not. Let's just see. I'm going to say valid. Oh, okay. Guess it's not a reserved word, and this should be okay. All right. And you should use useful variable names. It's just good practice stuff, but it's personal preference. Or you may be working on a team and you have some sort of convention. I'm going to sneeze. Right. Oh, here's the reserved words. All right. Oh, nice. Okay. All right. What's next? Objects. So this is a little bit different than other programming languages. For Python, it's like everything is an object. Python interpreter is a program that runs on a computer, just like an internet browser or a text editor. Instead of displaying a web page or creating a document, the purpose of the interpreter is to run, we're talking about the Python interpreter, is to run Python programs. An object represents a value and is automatically created by the interpreter when executing a line of code. So example, x equals 4, x, is a variable, and when it encounters this statement and executes it, it actually creates an object called 4, or that's an object that represents the value of 4, and that gets assigned x. Programmer does not explicitly create objects. Instead, the interpreter creates and manipulates objects as needed to run Python code. And so it's kind of it's kind of important to know, because there's going to be times in your thinking that something doesn't seem right because of you assigned a list variable to some other list and thing. It's not behaving the way you think, and it's because Python makes everything an object, even something so simple as a scalar value. So anyway, it's creating new objects. Okay, so this kind of takes us through that. You should click through this. Interpreter creates a new object with the value 4 because it's executing this. And then it once the 4 is printed, the object is no longer needed. It goes in the trash. Creates x. Okay, it's objects is stored there. All right, I guess we can think of it that way. Objects are retrieved from memory when needed. That's it, I got my points. Okay, so name binding, it's a process associated with of associating the names with the objects. And an object can have more than one name bound to it. So you have a single object and it can be referred to using more than one name, and that you got to be careful with that, because if you change the value of an object using one name, and then it changes the value of the other name and so on. So it's can get, I just kind of try to stay away from being fancy like that, keeping all my variables the same and keeping one objects to variables and not try to mix them and so on. But anyway, so each Python object has 3 defining properties. It's got a value and a type and an identity and a unique identifier that describes the object. And that sometimes can be like the memory location. Okay, a type is like, is it integer? Is it an integer or a string? And then the value is the actual value. The type of an object also determines whether or not it's changeable. Changeability indicates whether an object's value is allowed to be mutated. Oh, I'm sorry. Mutability indicates whether an object's value is allowed to be changed. Integers and strings are not changeable. Modifying their values with assignment statements results in new objects being created and their names bound to the new object. I guess the old object gets thrown away. See, to me that's kind of weird. You know, you don't just change the value. You make a new one and then throw away the old one. Anyway, that's how they want you to think of it in Python. The identity of an object is a unique numeric identifier, such as this or this. It's like memory location. And there's an ID function, so you can get at it. There you go. There you go. So anyway, here's a run the following code to observe the results of this. Create a new object called age. So I'm just going to run this and see what it does. The year equals, prints the value. The type of birthday year, what's the type of birthday year? It's an integer. And what's the ID? This is probably like the memory location. It looks like it could be a memory location. This is the birthday month, is a string. See, here we've assigned some. Now, what happens if I do something like, okay, so birthday month is a string. What happens if I make this 4? Oh, now it's an integer. All right. Okay, so anyway, it's kind of interesting. Is it called type? Type finds the type of an object. Oh, okay. All right. Okay, it is 2:29. You know, okay, so I'm going to end, but I just want you to know that it's quite common for me to run a little behind, and usually I catch up. I'll schedule 2 classes in a week, or sometimes I've even scheduled 3 classes in a week before to catch up. But the beginning of September is especially busy for a lot of us instructors, because a lot of stuff is due, and a lot of stuff we full-time instructors, about half of what we do is teaching. And the other half of what we do is a bunch of duty stuff. It's a bunch of committees and doing stuff for accreditation, and there's all kinds of issues. And so and all that stuff gets started in the beginning of the semester. So I don't know about next week, if I'm going to have 2 classes next week, but certainly the week after that. Well, you know, so I may fall a little behind in the beginning, but then we'll catch up. Also, notice these later chapters, I've allotted 2 weeks for them. I should have allotted 2 weeks for some of these up here. But anyway, all right. So that takes us into chapter 2, and we'll continue this next time. Do you have any questions? All right.
For the class, the second class, when will you be holding it? If you are going to be doing it this week?
No. So I'm not. So I've already made the schedule for this week. Yeah, you can depend on that. You can rely on that too. I send out the announcement I try to do it on the weekend, and so I said this week already. I already said it's just gonna be once this week. So we're done with this week.
Mhm.
And so next week, so this coming weekend, you'll get another email, 1 or 2 weeks. Why did you want to have another? Did you want to have
Oh no,
another?
just out of curiosity.
Just
If
curious,
you,
yeah.
yeah.
Yeah, there's, again, I've been getting a few questions on this. There's no real deadlines, and it's because it's auto graded. And so if I fall behind, that's fine. We're not really falling behind because, and so I will, if we do fall behind, then I'll be sure to catch you up by, helping you through the stuff a little bit more. But anyway, all right.
Okay.
So I will
Thank you,
see you
Professor.
next week. All right. Take care.